The common misconception about fiber. The words simplex and duplex do not describe multimode and single mode. Rather, they describe duplex as two fibers joined together side by side, as you can see, and simplex, just a single 3 millimeter, 2 millimeter, 1.6, whatever, single fiber jacketed. Common in patch cords, duplex being the domain of transmit and receive, commonly found in Sam Charlie and Lima Charlie. Simplex, commonly found in Frank Charlie and Sam Tom STs. This being a 3 millimeter duplex, this being a 3 millimeter simplex. Further, let's describe the size relationships between different types of glass. This being 1.6 millimeters, comparable to 2 millimeters. 2 millimeter duplex, 1.6 millimeter duplex, comparable to 3 millimeter duplex. When ordering, it's important to understand the differences and why you would want them. All of them have the same piece of glass inside. However, for obvious reasons, such as size and flexibility, you might want to choose one over the other. Let's look at simplex. This being a 2 millimeter tactical simplex versus a 3 millimeter tactical simplex. Again, they always have the same thing inside. This is a 900 micron jacketed piece of single mode glass. Same contents in here. This is simply built up to be more rugged. This one is custom manufactured to be used inside of composite cables. Composite cables being cables that have varying types of cable all in one jacket. Another form of tactical, it's a multi-core tactical, this one having 4 strands. This one is referred to as a TAC 4, comparable to a single strand of 3 millimeters. This one actually has 4 strands of 900 micron inside, while this one has a single strand of 900 micron inside. This cable is 3 millimeters approximately. It actually has 4 strands of glass inside. Those 4 strands are actually 250 micron. Very difficult to see. Oh, considerably smaller than the 900 micron inside. But the glass inside is still standard 125 micron. So even though this appears to be substantially larger, the inside contents of glass are exactly the same size as these strands. This is just built up. This you would run for infrastructure. This one happens to be a multi-mode. As you can tell by the color. However, the internal pieces of glass follow the strict color code of fiber: blue, orange, green, and brown. Now I'd like to demonstrate the termination of an ST connector. It's the closest approximation of a B and C connector commonly found in the broadcast industry, the ST being the most used field connector. Has a boot, has a crimp sleeve, connector body. Attached to the connector body is a protection sleeve. That's to shield the glass as it comes through the zirconium. We're going to remove the jacket material, very small pieces. This is tactical 1. You can't take it in large pieces. No. Small strips. leaving the yarn behind to crimp as if it were a braid. As you can see, comparing the two, the jacket is removed to allow the glass to extend past the zirconian. Using Kevlar shears, not scissors, your small serrated pair of scissors to cut back the yarn to crimp. Now I'm going to remove small pieces again of the interior jacket, this being the 900 micron jacket, to expose the 125 micron interior. Now you would wipe this glass down, alcohol wipes. You would take the connector. You would use either a cook epoxy, overnight epoxy. In our case, we use a 5-minute cook epoxy, 105 degrees Celsius. You would inject it into the syringe, or inject it in with the syringe, until you see it come out the other end. The connector would then be slowly attached, allowing the glass to come out the end, allowing the yarn to form a flower at the pedestal of the connector, and then in this case we would crimp it. We're going to crimp it with 178 on the stepped ferrule, common to miniature BNCs, and 151, very uncommon, to crimp down to the jacket. This connector is retained by the crimping process. However, internally it's filled full of epoxy. The boot is slid up, and the whole thing is put in an oven for, in this case, 5 minutes at 110 C for a quick cook epoxy. Later, the protection sleeve will be removed, and we will use a scribe to slowly remove the excessive glass, and then it will be inserted into a polisher, big large bench polisher, or hand polished. Glass, by its very nature, needs to be constantly cleaned and maintained free of dirt and debris. As illustrated earlier, these are all positively engaged contacts. The two contacts through an alignment sleeve are actually mashed together, so any debris would immediately transfer to the other surface. In this instance, we are going to use a video inspection scope. Several different tips are available for these for all different types of connectors. In this case, we're going to switch over to a 2.5 millimeter. 2.5 millimeter is very, very common. Found in the ST connector. The SC connector, phonetically I would sound it out, Sam Tom, Sam Charlie. Constantly problems arise from people assuming the pronunciation Sam Tom, Sam Charlie of SC, SC, FC, LC. All those connectors sound very much alike. So it's best to either put it in print, exactly what you need, or actually sound it out phonetically. And in this case, I always say Sam Charlie's, Sam Tom's. The connector could be inserted into the video scope. So look at the surface area of the contact. Each contact can come with a different diameter. In this case, 2.5 millimeter into a 2.5 millimeter tip. Other tips available, 1.25 millimeter, commonly found in an LC connector, the Lima Charlie, as I would refer to it. Or in the case of the Lima connector, a 2.0 millimeter, which is another size tip altogether. The surface area of the contact still only has an opening of 125 micron, and the core is only 9 microns in diameter. Even the merest touch to the surface of the contact would completely obliterate the glass, scattering it. One little particle of dust dead center could cause you as much as 3 dB of attenuation. If it is actually mated while dirty through a coupler, you could actually transfer it to the other connector. That particular oil, in this case, left uncleaned, would eventually harden, much like plaque, and simply wiping it off would not be enough. Popular for cleaning are one-click cleaners. They're basically a piece of string is pulled over the top of the zirconium. The zirconia is inserted in, one click, re-inspect, and then you should have a clean connector. Then reinstall a dust cap. One click is available for almost all sizes of contacts. The 2mm Limo F2 also has a one-click cleaner available for it. 1.25mm, commonly found in the LC or Lima Charlie. Again, each tip is available, in this case, 2mm for video inspection of Limo's F2 contact. To examine the surface area to see if further cleaning is necessary. Cleaning the Limo connector, which is the F2 contacts, you would normally switch to a tip designed strictly for 2mm. Same process. This tool allows you to reach down inside the connector to visually inspect the contact. This is where the one-click tool plays an important role, as it's much more difficult to reach down inside to wipe the surface off. So, Stickler makes let's call it a reverse Q-tip. It's where the swab material is embedded in an open tube and goes down over the surface of the contact. This is important when trying to remove built-up material. You would go through several attempts at wiping with dry, wet, to break away the material buildup in the F2 contact. Now, always ending with a dry and usually with a final click. You don't want to leave any moisture behind. Moisture is no good. The male connector, always remember to put your cap back on. The male connector has a protection sleeve deep down inside. It's absolutely necessary to remove it. You don't want to try to work through the protection sleeve. The protection sleeve has a piece of zirconium in it that's only in the form of a C. Any pressure to the outside would actually cause it to crack. A bad protection sleeve, alignment sleeve, is worth about 20 dB of attenuation. You simply thread the tool onto the alignment sleeve and pull. Now it is attached to the extraction tool. Now you can stick your inspection scope down inside. Same process to view the contact. Again, there's almost no other way of viewing this without a video scope with the proper tip. Same process to clean it. You can either use a stickler, wet, dry on several, and or a one-click tool. Replacing the alignment sleeve is just the reverse of the operation. Simply insert it till it snaps and unthread the tool. And again, keep everything capped. Dust is your enemy. It takes very little dust to wipe out a signal. So, Neutrich's version of a SMPTE interface has two contacts down inside. Those contacts are basically LCs. They're housed way down inside the connector. However, reaching them is often difficult. I often suggest that you remove the head of the connector. You would simply retract the wavy washer and slowly rotate the back. Once the back nut is cleared of the threads, you would pull the head away. Inside you will see that there's two LC connectors. You can have a one-click cleaner for the LC connectors, and you would switch to a 1.25 tip to visually inspect them. Be careful. It's very easy to snap off the head of an LC connector. As we can see, this thing is an utter mess. We would simply apply the one click and reinspect. We have removed a substantial portion. Inspecting the other one. Exactly the same case. LCs are very prone to dirt. I would recommend doing this often. Again, the one-click tool. Voila, much, much cleaner. To reassemble, line up the fat polarizing key to the notch, completely seat that, holding this steady, bring the back nut up. Rotate it, you'll hear clicks, the clicks are necessary. A couple of clicks till the washer seats again, and you're done. It is a much better process than actually trying to reach down through the interface of the connector to clean the contacts. Which you can do. They actually make a special insert for it. Another common technique for surface cleaning is basically a chem wipe. It's a lint-free wipe and some alcohol. You take the chem wipe, apply gently to the surface area, rotate one direction, clockwise if you would like, but only rotating in one direction. Works the dirt from the inside to the outside. A dry wipe to remove the residue, and again, simple reinspection by the video scope. See if it's adequately cleaned. When excessive buildup occurs, you can use a stick cleaner, which is a little more rigid compound embedded into a plastic tube known as a stickler. Now, it's always best to first attempt to dry wipe the contact. If necessary, apply a little bit of alcohol. Wipe again across the surface. And in this case, a final wipe to remove any moisture residue, and again, reinspect the surface of the contact. In cases where contacts are embedded in a multi-pin connector, such as in a LEMO connector, this being a LEMO connector. There we go. As you can see, there are two pieces of glass. So the F2 contacts, two low voltage, two high voltage contacts. However, reaching down inside of this connector to wipe those contacts is not possible. That's where it would be absolutely necessary to own something like the one-click cleaner to be able to reach down and clean the surfaces of those contacts. In the case of the LEMO male, they're actually protected inside of the connector by two alignment sleeves. Those alignment sleeves would have to be removed. A threaded tool, which actually is called an alignment sleeve removal tool, is then inserted and threaded onto the alignment sleeve, gently pulled to extract the alignment sleeve, allowing you to insert the tool down inside, clean the contact, switching back to the 2mm inspection tip. We can then insert it down inside of the connector for video inspection of the surface area of that contact. Now, if we need to be more aggressive, that is when you would utilize a stickler cleaner, rotating again, one direction only. So you may have to do this several times, inspect it, and apply more. Sometimes you need to apply alcohol. Then you would use a dry version of this to clean the tip. Then you would reinsert by pressing it in and unthreading it. It's best never to stick anything down through the alignment sleeves, as they're just a C-shaped zirconian, very fragile, much like seashell. One important aspect of developing a good polishing technique is the ability to actually measure the polish. That's where this comes in. Even though it's priced like a small automobile, it is an absolute necessity for measuring the geometry and surface area of a contact. The contact has been pre-polished to a particular fiber standard. However, once the glass has been installed into it, it's necessary to polish the glass without distorting the original specification of the connector. These are millionths of a meter. It's impossible for the human eye or a handheld videoscope to actually measure any of those surfaces. That's why viewing it through an interferometer, which will give you a digital three-dimensional image, is necessary. The interferometer is used to examine polished contacts on a scale of a millionth of a meter or more. There's absolutely no other tool and no other way to properly examine the finished product of your polishing techniques, or to guarantee that you're meeting and maintaining industry standards. Videoscopes are wonderful for cleaning. Will never show you this type of detail as you see on the screen right now.